So, in the last class, we talked about different NLP techniques, right? We talked about text processing, and we did that using the NLTK library, right? So, NLTK basically stands for Natural Language Toolkit. And so this is what NLTK stands for, and we did the text processing using this. So now what we will be talking about is we'll be talking about TextBlob library. So all these libraries are basically to solve or do some text related task only, right? So lemmatization, stemming and all those stuff we can do using these libraries. We have to talk about different libraries is because see, you might think of some task that might be done well with the NLTK library, but sometimes there might be some other library which might perform better at it. So you should be prepared for everything. You must know all of these things, even though you might not require them. At some point, some place you might require them, all right? So that is why it is important to know all of this, and hence I am forcing and teaching about all these different libraries, okay? So now what we will be doing is we'll be talking about TextBlob now. So TextBlob is basically a processing library, right? So these are the different features of TextBlob, okay? So you can do noun phrase extraction, you can do parts of speech tagging, you can do classification, you can do language translation, detection, tokenization, parsing, and a lot of things you can do here, okay? So the very first thing, so here what there is given is, see, these are the ways in which you can download the TextBlob library, okay? So this is because if you want from a conda environment, if you want to download, okay? But since I want to keep this in my base environment, I do not want to create another conda environment, so I'm just going to do it here, okay, in my library, in my Jupyter notebook itself. So as you can see, I already have installed TextBlob, hence the requirement already satisfied message shows up. So now what I'm going to do is basically import TextBlob. Okay, now let us create our very first TextBlob. So what does TextBlob mean? So TextBlob is basically a variable for storing, variable or a type of variable. So you have string, right? You have string, you have integer, you have all those things. So in the same way, a type is TextBlob. So this is a TextBlob, and we'll be creating a TextBlob here. Like we'll create a string, here we'll be creating a TextBlob. So the name of my TextBlob is Wiki. So now let us get all the parts of speech for Wiki. So you can see you have I, which is a pronoun, I suppose love is a verb. And then in that way you have all these things. Again, you can go back and look into the library and see what each of these represent. But yeah, so what this has done is basically we have done our first task, that is to identify the parts of speech. Okay, so now for every sentence or for every text blob, in fact I'll be calling it text blob. So for every text blob you can do different tasks, and the first task that we have done is basically identify the parts of speeches. Okay, now we'll be extracting our nouns. Okay, so noun phrase extraction. So out of all this language processing, this is basically a noun phrase. Okay, and yeah, so once that has been done, the next thing that we'll be doing is basically doing a sentiment analysis. Okay, so here if you run this, what this does is basically for every text blob it will give you a sentiment. Okay, if this is a positive statement or this is a negative statement, or how subjective this is. Okay, so you can do that, and you can check your sentiment subjectivity also. So how subjective is the sentiment itself. Okay, so this is basically the same as here. So polarity basically means polarity lies between -1 and +1. -1 being that it is a very negative sentence, +1 being it's a very positive sentence. Okay, and anything between that you can understand on your own. 0 will mean that it is a neutral sentence. This is 0.39, which is equal to 0.4. That means it is a positive sentence. All right. So that we have done. Now what we'll be doing is we'll be doing tokenization. So tokenization in TextBlob. So this is nothing, you just have to write zen.words. Once you have the text blob, then you can just do dot words, and there you have the whole tokenized thing. It is saved in a word list. Alright, Then you can do zen.sentences. Now this will be basically another form of tokenization. If you remember, we talked in the last class, there were two types of tokenization, right? There were actually many, but the more different kind of were two. Okay, so one was word tokenization and the other was sentence tokenization, right? So we had two types of tokenization, and yeah, so that is what we can do from here also. In TextBlob also we can tokenize in two different forms. You can do dot words, so it will give you a list of words. You can do dot sentences. Okay, so this will give you a list of sentences from this. So you can see it has 3 sentences and it has given me 3 sentences as tokenization. Now this is basically in TextBlob also, like basic string, you can go and do what is known as a looping thing. Okay, so you can loop over or the TextBlob item. Now what we will be doing next is basically we'll be getting TextBlob words and we'll be doing an inflection and lemmatization. So if you remember, what is inflection? Inflection was basically converting. So inflection was basically number to number in words, right? This was inflection. So we can do that. So here what the first thing that they have done is basically they have used dot words. That means this is a tokenization thing. Okay, so this has been tokenized. Next what it will do is basically singularize. So singularize and pluralize is basically to write the singular form of the word or the plural form of the word. Alright, so just like any string, in TextBlob also you can use all the array functions. Alright, so array functions of like slicing or getting an index value. So that is what is happening here. Okay, sentence dot words number 2. So number 2 is spaces and you have to singularize spaces. So if you write dot singularize, it will give you space. That means it has been singularized or you have been given the singular value of spaces. Then you can use pluralize. Pluralize, what this will do is basically it will convert your single into plural form. So you had use, it becomes uses. Alright, the next thing that we are going to do is lemmatization. If you remember, we had two things, right? We had stemming and we had lemmatization. The only difference between these two is, see, both of them are responsible so that each word gets back to its original basic word, right? But the only difference is basically sometimes stemming, it gives you words that do not mean anything, or even if they do not is not easy to understand. Okay, so stem words difficult to understand. Lemmatized words easy to understand. So these are easy to understand. Alright, so this is the basic difference between stemming and lemmatization. Okay, so let us run this. You'll be able to see. So lions is the word. If you lemmatize it, it comes back to lion. Alright, in this way went lemmatizes to go. And here you can give what part of speech you want to use. If you remember, we did that in the last time also when we were using the NLTK library, right? So V means you get the verb form of it. Alright, so the verb form of went will be go, the lemmatized word form. Alright, the next thing that we will be going to do is for each word that is inside there you can use synsets property. Okay, so we'll talk about this, but yeah, synsets is basically a way in which you can look up for words. Alright, so let's say you have a word length. Okay, so this is the first synset, the second, third, fourth and fifth. Okay, so these are the definitions and they are also known as synsets. So if you run this, it will give you all the definitions of the word length, right? In the same way, if you want, you can compare two different words and see how similar they are using this property. So you will be able to see octopus, the second meaning of octopus and the third meaning of shrimp are 0.11% similar. Alright, next we'll be talking about word list. Okay, so word list basically means just like list that you can use or make using strings and everything, here also you can make word list. They are known as word list, and you can make it as text blob. Okay, so once you have that, you can do dot words and you'll get all the words. You form the word list. Next, if you remember, what we were doing now till now is basically we were taking a particular word from the word list, so number 2 or number 3 or something like that, and then we were pluralizing it. Here we can pluralize the entire word list itself. Okay, so then it becomes the whole. So you had cow, sheep, octopus, it becomes kine, sheep and octopods, right? So in this way you have pluralized the whole thing. Okay, then you have spelling correction. So in spelling correction, if you see here, Czechoslovakia spelling is incorrect, so here it corrects the spelling. So you just have to write dot correct. And you also have something known as spell check. So spell check basically returns a list of spellings. Okay, that should be there. So it will give you, let's suppose there is one spelling, you have written it wrong. So this will give you a list of spellings that are, or a list of words that are similar to that word, what you're meaning to say, so you can correct your spelling out. Okay, so here you can see longitude spelling has been given wrong. So if you do spell check, it gives you out longitude this spelling, and it says chance are that this is the correct one. So 100% or 1 probability is the chance that this is correct. Next, you can get words and noun phrase frequencies. Okay, so if you write this a sentence inside a text blob, you get a text blob, and then you can do word counts for a particular word. So here you have she sails seashells at the seashore, right? So here if you do a word counts for C, you'll see there are 2 C's here, 1 C here, 1 C here. So you get 2 as the output. Alright, in the same way you can also do it in this manner also. There is another way to do it, using, instead of using word counts, you can use words dot count also. So the whole thing means the same thing. Then you can do one more thing in this manner. Here what they have done is they have written case sensitive is equal to true. That means this will only match with C where the first S is capital, alright. And if that is not there, then it will give you a 0. Next you have noun phrases dot count. So this will basically give you phrases, noun phrases, and since there are no noun phrases for C, it gives you a 0. Next, what we will be doing is we will be understanding about translation and language detection. So now this is some of things that you can use for translation, for understanding and everything. Okay, so let's say I have a sentence, something is better than nothing, and I want to translate it to HI. HI means Hindi here. Okay, so it will translate this to Hindi word. So kuch nahi se kuch bhala, this is what it is written here. So that is one thing. Here you can see you have this written in, I suppose, Chinese or something. So you can translate this into English. So once that has been done, you will be able to get better than nothing. Okay, so this is basically a translation part of it that you can do using TextBlob. Now this was not there in NLTK. Then here again, along with translation, you can also detect the language. Okay, so here you have something written in Hindi, and you can write just detect language, and it says this is the language. Okay, then we are talking about how text blobs are very similar to Python strings. Okay, so in Python strings, like I was saying, what could you do? You could use indexes and everything. So here also you can index, you can slice. So if you do this, you can slice data is a new and F. So if you remember this word Zen here, so this was a text blob of Zen, right? Data is new fuel, explicit is better than implicit, simple is better than complex, right? So if we do that and slice it out in that form, what will you get? Data is a new F. Okay, nothing else. You can do dot upper just like you could do it in string. You can do find also. So it will show you where it starts from. So I want to find Dan. Okay, so Dan starts from here. So it will count the places here, and this T comes in the 39th position. So it will give you 39th value. Alright, and not just that, you can also do comparisons. So even though text blob is a different form and string is different, even then you can compare these two. How can you do that? So you can compare it to, using this equal to sign. We'll come to that, but here what we are doing is we are using two text blobs. So one is Apple, one is Samsung, okay, and then we are comparing two text blocks among themselves, okay. So I am comparing text blob Apple with text blob Samsung, okay. Since A comes before S, obviously A blob is going to be smaller than S blob, hence you are getting a true here. And now what we will be doing is, you have text blob, we will be comparing this text blob to a string value, and you can see if you run this, it comes out to be true. And then the next thing that can be done using text blob is basically concatenation tasks. So just like strings, you can concatenate here A blob plus, you can write and plus S blob. So it's Apple plus Samsung, it comes here. And if you can format it, you can also write it in this manner, just like you do it in normal strings, okay. So what I'm going to explain here is, what this means is, see, despite anything that you're doing, if you are doing this text blob also, it has a lot of features that match to a string, alright. Then we have something known as n-grams. You might have heard of n-grams when you might have been doing about machine learning. If not, n-grams basically means the number of words that we will be taking together. So here n-grams is 3. That means we will be making pairs of 3 words, one after the other. So you have text blob now is better than never. So your first list will be now is better, 3 words. The next will be is better than and better than never. Now you cannot make any more, so you can skip that. Also, you cannot just randomly shuffle and make those, alright. So you have to make sure that it is in the same order. So that is how you can make n-grams also. If you change this n-grams to 2, so in that case you can see now is better than never, right. Next thing what we'll be doing is, basically we can also see the start and the end index of each sentence, okay. So you have sentences, right. Here you had the sentence, the Zen sentence was data is the new fuel, explicit is better than implicit, and simple is better than complex, right. So if we go back down here, this is looping over all the different Zen sentences, and for each Zen sentence it shows me this is the start index, this is the end index, alright. So this is the whole thing here. Now what we are going to do is, basically we are going to build a text classification system using TextBlob. So here we have a set of sentences in train, and also we have a list of sentences for test, okay. So these sentences, they are basically positive or negative sentences. That is the whole task of this. So we are making a classifier that is able to say whether the sentence is positive or not, and we will be doing all of this using the TextBlob library, okay. So let us run this. Now what we are going to do is, basically TextBlob itself has classifiers, okay. So we'll be calling the knife based classifier from here, and we'll be giving the name CL to that, the variable CL to that, to this classifier, and inside the classifier we'll be fitting train, alright. So this is how you do it. So now CL has been named as knife based classifier and train has been fed into it, okay. So now it understands this. So now what you can do is, basically you can just ask it to classify. So if you write this is an amazing library, it is able to classify, okay, this is a positive statement, okay. So it becomes as easy as this to actually train and test in TextBlob. So this basically makes our task way more easier. So here you can see you can also get label distribution. So you can also get the distribution of the actual value that is there, alright. So here you have instead of classify, we are doing prob classify to get the probability, okay. And the sentences, I am suffering from cough and cold. So if you write prob distance dot max, so in that case it will give you negative, because the sentence is negative. I am suffering from cold and cough is not a positive sentence. So if you round it off, you can actually get the value that how negative this is. This is 0.81 negative. So in the same way you can find out how positive this is. So it is 0.19 positive. So this gives out the probabilities. So the thing that happened is, see, prob distribution gave us two values, okay. One value was for the positive value, the other was for negative value, okay. So positive, it is only 0.19% positive or 0.19 positive, and 0.81 it is negative. Alright, so we are rounding it off. If we remove this round off, okay, so it will give you some values, but see, if I put this, so this is the actual value. So I'm just rounding it off to 2 digits because we do not need so many digits. So what this whole prob distance basically gives is, it gives us two values, the value or the chances that it is positive, or the probability that the sentence is positive, and the probability that the sentence is negative. Okay, so it gives you that. I am doing dot max, so out of these two, which is maximum, negative is maximum, so it will give you the output as negative. Alright, the next thing that we'll be doing is basically classifying it again. But this time, instead of using the classifier and calling the knife base like this, we'll be using it in a different format. Alright, so this is also another way of classifying. So you were doing CL here, and then you called the knife base classifier. Inside that you fed the train data, right? Here what you will be doing is, you will be calling TextBlob, you will be writing the sentence, and you will just write classifier equal to CL. This is another way of classifying. Alright, and once that has been done, what you can do here is, you can go and you can classify sentences within a TextBlob itself. So I have two sentences here, and for each sentence it will give whether this is a positive statement or a negative statement. Alright, so it gave me this is a positive one, this is a negative one, and overall it turns out that this is a positive sentence. And after that, what you can do is basically, you can also check the accuracy. Alright, so I had the train data, I fit the train data and everything. Now I have the test data also, I can fit the test data, and I can find the accuracy. So it is 0.83% accurate. That is, it is 83% accurate, 0.83 accurate. Now you can also see informative features from here. So it will show you what are the words, how the whole thing is adding, and other informative features. Alright, you can go here and understand and read this. I don't have to go through all this. The next thing that you can do is, you can also update your classifiers with new data. Right, once it has been updated, you can check the accuracy again. Now this time the accuracy is 1. Also, you can even extract features from knife based classifier itself. Okay, so here if you see, it gives you the first and last words of a document. Okay, so you have the document, you find all the tokens from it, and it gives you the first and last document. Okay, now here features, what you can do is, you can use the end feature extractor, right? And you got the features. Now you can check whether this is true or not for the document itself. So here it will check whether the last word is love or not, and the first word is I or not. Alright, so if you remember, our sentence was I love. Okay, so it passed through here. So what this is basically doing is, this basically helps in extracting some features from it. Okay, so in the same way you can use this in knife base also, right? So here, now let's look about in this. Okay, so I have the knife base here, CL2. Alright, I have run this for my test, and in test my feature extractor is end word extractor. So end word extractor was basically this one. This was used to extract my features. Now what here I'll be doing is, basically I'll be running this on TextBlob, and I'll be using the classifier CL2, and I'll be wanting to classify this, and this comes out to be a positive statement. I am excited to try my new classifier. So these are different ways. In which you can train or classify. I would say the most I use is the first one, because this is kind of the easiest, but you can try out different things. Obviously it is always good to know everything, and I hope you enjoyed this whole video of TextBlob. It just basically shows how we can use different libraries. This is a very simple library, it is very easy to understand. If you are still having some problems, go again into the video, else go over to the documentation of TextBlob. I hope you enjoyed the video and keep learning.